Hi everyone, welcome to this lecture. So in this lecture, we will learn how to implement cross-validation in Python. So this is our project 7 of this section. So here I am in my course folder, which is known as regression analysis. This is the course folder for this section, which is also known as regression analysis. So here I am at my project 7. And here it is a cross-validation. So click on this file so that we can open it in our Google Colab environment. So this is our project 7. And here we are going to implement cross-validation in Python. So I need NumPy, I need Pandas, I need Matplotlib, and I need to import train test split from Scikit-learn.model selection. And I also need to import metrics from Scikit-learn.metrics. Let's run this cell to import all these necessary Python libraries. Now we know that if we want to use a dataset from our folder, we need to mount the drive and we need to set the path. Since I want to use the dataset known as regression underscore data, and this dataset is present inside the folder called regression analysis. Therefore, in order to read the data in Google Colab environment, we need to mount the drive, we need to set the path. So in order to save the time, we have already mounted the drive and we have already set the path. So if we see, the path is drive, my drive, course material, supervised machine learning, and inside the supervised machine learning is the folder regression analysis. And inside this folder, we have a dataset known as regression underscore data. So we can also confirm from this that we have a drive, then my drive. Inside my drive, there is a course material folder. Then inside course material, we have supervised machine learning. Inside supervised machine learning, we have a folder known as regression analysis. And inside regression analysis, we have a data known as regression underscore data. So this is the data which is present inside the folder regression analysis. Now the drive has been mounted, the path has been set. It's time to read the data. Here we have read the data. Let's see the data. Now the data has only 30 samples from 0 to 29. It has one feature, that is independent data, and it has the target variables. It's time to see the shape. Let's see the shape. So we can see that the shape of the data is 30 by 2. 30 are the samples and 2 are the column. One of the column is feature and other column is the target variable. Now we can extract X and Y, that is feature and target variable from the data set. Let's run this cell. So we have extracted the feature and the target, and here is the shape of the feature. It is 30 by 1. That is, we have 30 samples for the feature. Now it's time to perform train test split. So for train test split, we are using a function train underscore test underscore split. The first input is the X, that is feature. The second input is Y, that is target. And the third input is the test size. So we want test size is equals to 0.2. It means we want 20% of a data as a test data and remaining 80% data as a training data. So when I will run this cell, I will get 4 output. That is the training part of the data, the testing part of the data, the training label, and the testing label. Let's run this cell. So we have splitted our data into testing and training. Now it's time to apply linear regression. So linear regression is present in sklearn.linear underscore model. Let's import this. After importing this, here we are instantiating the linear regression. We call it LR. Here we are fitting our linear regression to our training component of the data, and we will call it linreg. And then we are fitting linreg. We are getting prediction by using linreg on our X test. So here we are getting the prediction from the test data. So we are importing linear regression. We are instantiating linear regression. We are fitting our linear regression model to the training data. And after getting training, we are getting prediction from the testing data. Let's run this cell. And here we can see the value of root mean square error for the test part. So np dot square root matrix dot mean squared error. Since we have the prediction, we can get the root mean square value for the data. So we are importing a matrix from sklearn. If I run this cell, I will be able to root mean square error of the data. So the root mean square error is 7059 point something. So basically what we have done till now, we have read the dataset, then we split the dataset into training and testing. We apply linear regression model, and the root mean square error is 7059. Now it's time to apply cross validation split. So we have learned in the previous lecture that cross validation is another kind of split. Let's split the data according to cross validation and see the performance. So in order to perform cross validation, I need to import k-fold from sklearn.model selection. I need to import cross underscore validation score or val score from sklearn.model underscore selection. Also from sklearn.model underscore selection, I need to import cross underscore val or validation underscore predict. So I am using a 5-fold validation. So this k is equals to 5 represents the number of split. So in order to get the k-fold or the cross validated data, I need a function k-fold. Here I am passing two input parameters, that is number of split, which is equals to k, that is 5 here, and shuffle is equals to true. So shuffle equals to true means that since we will split the data 5 times, and we will evaluate the data 5 times according to the concept of cross validation, which we learned in the previous lecture, that after every split there will be a shuffling of the data and then the other split will take place. That is, after split 1 the data will be shuffled and then split 2 will take place. Then after split 2 the data will shuffle and then split 3 will take place. So here for performing multiple linear regression model, we are instantiating a linear regression model and we call it only model here for the cross validation purpose. So here I am applying a cross validation to evaluate my model. So I want to get the score of the cross validation. So the function is cross underscore val underscore score. So the first input is the model which I have instantiated. The second input is the feature, then the target variable, and here is the scoring matrix. So I am giving negative underscore root mean squared error. So basically this is a root mean square error, but we are getting the negative value from this function. So the reason of applying a negative is that this is the standard stuff. This is the requirement of the Python, or this is the requirement of the cross underscore val score function. Now CV cross validation is equals to CV. This CV we have calculated here that we want to split our data into 5 components. That is, we are going to perform 5-fold cross validation. Then number of jobs is equals to -1. Now number of job equals to -1 mean we want to increase the speed of processing. Like if we are using more than one processors in parallel, then if we want to use all the processor, then we have to set number of jobs, or n underscore jobs is equals to -1. So this is a cell which is going to implement cross validation for me. That is when the split is equals to 5. So let's run this cell. We have seen that name k-fold is not defined. It means we have to run this cell first. And now we have to run this cell. So we can see that we get the 5 values. The reason is this is the value of the first evaluation of the cross validation. This is the value of the second evaluation of the cross validation. This is the value of a third evaluation of the cross validation. So it means we have 5 values and all of the values are negative root mean square values. The reason of the negative root mean square value is that our scoring matrix for cross validation is negative root mean squared error. So we can see that we have 5 values for our score or for negative root mean square because we have split the data into 5 folds. Now it's time to get the average of these 5 values and also to transform them into a positive value. So we are taking the absolute value of the scores and then we are taking the mean of all these 5 values. When we calculate the mean, we will get value 5542. Now this 5542 is the root mean square error, which is calculated after a cross validation split. And that was the error which was calculated after a regular train test split. So I will call it a regular train test split because it is other than the cross validation split. And here the inputs are X and Y. And we split the data into 80-20 ratio, that is 80% for training and 20% for test. Now, here in cross validation, we split the data into 5-fold. So this function is taking all the samples of feature and all the samples of target, and it is splitting a data into 5 components. And for every evaluation, it takes 4 components for training and the 5th component for testing. Then for the second evaluation also, it is taking 4 components for the training and the 5th component for the testing. And here we are getting the root mean square score. So we have seen that how to implement the cross validation in Python, and we have seen that the cross validation split is performing better than the regular train test split. Now let's further compare the performance of cross validation with the regular train test split. Let's generate some unseen data, unseen test data. So the test data will have 30 samples here, and its minimum value is 1, its maximum value is 11, and here we are reshaping the test data. So this is our test data. We can see that its minimum value is 1 and maximum value is 11. Now, after generating test data sample, we are generating test labels. So for this particular example, or for this particular project, we are equating our test labels equals to training labels. So here the test labels are the same as that of training labels, but test samples are quite different. Let's run this cell to generate the test label. Now first get the predictions without cross validation. So we have a test data, and the model we generated without the cross validation was lin-reg model. Let's apply this model to test data to get the prediction, and here we call it ypred_test. Let's run this cell, and let's run this cell. So we can see that we have calculated the 3 metrics which are commonly used in order to evaluate the performance of a regression. So we can see that root mean square is 9753. We can see that mean absolute error is 8020, and this value is 0.869, approximately 0.87. So this is the performance of a linear regression model, which is not trained on a cross validation, but it was trained on regular train test split. And we can see that this is its performance on a new or unseen data. Now let's see the performance of cross validation on this unseen data. So in order to get the prediction from the unseen data, now we have to use a function cross_val_predict, and the first input is a model, then the test data, test label, then the cross validation, which is 5, and number of job is equals to 1. So this is a very much the same sort of code which we have used for cross_val_score. So here we are getting the predictions. Now here the predictions are obtained. Now it's time to evaluate the performance of regression model with cross validation. So we have to calculate these 3 important metrics. So we can see that the root mean square on the unseen data is less than the root mean square, which is obtained without cross validation. So by comparing these 3 metrics with these 3 metrics, we can see that even on the unseen test data, the cross validation split is performing better than the regular train test split. So in this project, we have learned how to implement the cross validation in Python. We have also learned the performance of cross validation resampling, or we can say that the performance of a cross validation split is much better than the split which is a train test split, that is in which we split the data into 80% and 20%. So I hope you understood the importance of cross validation. So in this project, we have applied the cross validation with Python, and we compared the result of cross validation with the regular train test split. Thanks for listening, and I will see you in the next lecture.